Hello my friends, it's me Sudesh Tiwari from Butul. Today I am going to talk about one of the important topic from mathematical physics, that is tensor analysis. First of all, I want to describe about tensor. What does it means? Tensor is generally a combination of both matrices and vectors, and they are generally represented by an array of components. The array of components may be t1, t2, t3, and these components may be heading along x, y or z axes and are generally represented as the function of coordinate of space. Then I want to discuss about how do we classify tensor. Tensor can be classified as follows. First one, if a tensor has magnitude but no direction, then in that case we can say it is as a scalar tensor, or in another sense we can regard it as zero rank tensor. But if a tensor has magnitude and has only one direction, then in that case we can consider it as a vector tensor, and in another sense we can regard it as rank 1 tensor. But if the tensor is of if the tensor has two directions and has magnitude also, then we can call it as matrix, and it is of rank 2 tensor. So tensor can be classified in the following ways. So tensor can be generalized at last as the generalization of matrices. Today in my topic I want to discuss about the types of tensor. Tensor is generally of three forms. One is contravariant tensor, another one is covariant tensor, and the last one is mixed tensor. But in my first class I want to discuss about the contravariant tensor. In order to discuss about the contravariant tensor, first of all I want to consider two coordinate frame of reference. In one coordinate frame of reference there are components a1, a2, a3 ... an. But in another coordinate frame of reference the components are a bar 1, comma a bar 2 up to a bar n. And assume these two coordinate frame of reference are generally linked by an independent relation, which is given by the equation a bar j is equal to a bar j a1, a2, a3 up to an. Conversely, we can also say that the unique set a1, a2, a3 up to an, which is correspondingly related to another coordinate a bar 1, a bar 2, a bar 3 up to a bar n, can be related by the equation aj is equal to aj bracket a bar 1, a bar 2 up to an. It means that the two coordinate frame of reference are correlated to each other. We can generally correlate one frame of reference to another and another frame of reference to the previous frame of reference. So two coordinate frame of reference are related to each other by an independent relation. So here I mentioned a line also. This relation above define a transformation of coordinate from one frame of reference to another frame of reference, as I had already discussed about it. Suppose n quantities t1, t2, t3 up to tn are in one coordinate system having coordinates a1, a2, a3 up to an, are related to another quantities which are n quantities t bar 1, t bar 2, t bar 3 up to t bar n, having coordinate system a bar 1, a bar 2, a bar 3 up to an are represented by a transformation equation which is given in previous slide, in my next slide, that is t bar j is equal to summation k is equal to 1 to n delta a bar j upon delta ak tk. This is our contravariant tensor definition. So we can say, we can define contravariant tensor in this form also. A tensor of the form t bar j is equal to summation k is equal to 1 to n delta a bar j upon delta ak tk is called contravariant tensor. It is a simple definition where j runs from 1 to n. These are called components of a contravariant vector or contravariant tensor of rank 1. In fact, vectors are tensor of rank 1, as I have already said, and scalar are tensor of rank 0. For j is equal to 1 to 3 and k is equal to 1 to 3, the equation above can be expanded in the following form. When j is equal to 1, then our equation will be given below, that is t bar 1 is equal to delta a bar 1 delta a1 t1 plus delta a bar 1 upon delta a2 t2 plus delta a bar 1 upon delta a bar 3 t3. Here you have to say that a bar 1 is fixed, but in the denominator there is change in variable from 1 to 3, a1, a2, a3. Okay, and also t1, t2 and t3 are also changing because they are coordinate components. Similarly, for j is equal to 2, the equation will be given below. Similarly, for j is equal to 3, our equation will be in the following form. So you have to understand the value of j is running from 1 to 3 and k is also running from 1 to 3. So the equation will be changing in the following ways with the change in variable, but the coordinate frame of reference will be same. Similarly, the transformation equation for rank 1 is given below. T bar j is equal to delta a bar j upon delta ak tk. Similarly, we can consider transformation equation of rank 2. T bar jk is equal to delta a bar j upon delta ap, delta a bar k upon delta aq tpq. So t bar jk is in the numerator side, j and k is in numerator side, yes, while p and q is in denominator side. You have to understand. In case of contravariant tensor, bar will be in numerator side, not in the denominator side. If it will be in the denominator side, it will be covariant tensor. So this much is my class for today. I will discuss more about the tensor in our upcoming class. So this is my first class in YouTube. Hope you will